Gentlemen, ladies and gentlemen, we talk about what is sleep actually. So in the pipe, in the control volume pipe, you have a liquid and you have a gas here. So you have a velocity here. You see the velocity something like this. So in the middle usually is much faster. Profile. So what is this is a velocity profile usually, just ignore it. So in the case of gas and liquid here, you have a flow in the pipe. Which one is faster, the liquid or the gas? So much faster is of course is the gas fluid. This one is much faster as compared to this one is much slower because gas is much lighter than liquid. So that's why you have a slip in here, they call it a slip in here between a gas and the liquid. It's called slip. Okay. So and the second one is what is the HL. So let us get it off this slip first, and we talk about HL. This is called liquid hold up. And you have another one is lambda L. It's no slip liquid hold up. Okay, so what it means that this one is not a real thing. This knot is gotten from the data from the separator, and then separator go to and then become at the PT, a certain PT of surface, and then pressure and temperature at the pipe. So this one is taken from the taken from the data that we have at the pipe. So let's see what is the definition. The definition is you can see that lambda L is QL divided Q liquid plus Q gas. So this is just comparison of the Q of the rate. So it's not a real thing. This one is the real thing. So if you wanna see if you wanna make a logic on it, not more language to much easier to understand. Okay, first we have this level of liquid. By the time the liquid flows through the pipe, you end up with having this one is a gas, is much faster, and this one is liquid is much lower as compared to the gas. So if you imagine that the key actually is this equation. So if you see this one, I imagine that this one is HL in the end of the pipe. But the whole thing here is HL. So the volume of the whole liquid in here divided by the whole volume of a pipe is HL. So HL is gotten from correlation. It's not just a simple calculation like this lambda L. So usually researcher starts everything from a simple one. This is a simple one because you get the Q from surface and then go to the pipe. Q gas also from the surface going to the gas, and this is a liquid also. So you will find this one. And for liquid hub, it's more complicated than that one. So this is the simple definition of HL lambda L. So from this curve, you can see that the HL has to be larger than lambda L. You can see that HL has to be larger than lambda L. Okay, so this is the basic principle. Okay, and another one that we already mentioned in the previous video is VSL and VSG. You can see that key gas divided by AP and key liquid divided by, oh, it's the other way around. This is key liquid, this is key gas, and this is key gas divided AP, A of the pipe. So you can see that everything is divided by the pipe. If you have a rate, okay, like this, if you want the real thing, if you want to see what is the velocity of liquid, it should be that the rate of liquid divided by the area of liquid. But in this case, it's divided by area of a pipe. So that's why they call it superficial liquid velocity and superficial gas velocity. They call it superficial because it's superficial. Superficial is something that is not the real thing. It's something that superficial is dipacak-pacakin apa itu, di superficial. So if you see what the meaning of superficial, you can see it from the Google what you call it, Translate. It's not real thing, so that's why they call it superficial. Okay. Why they use this superficial? Because what we have, researchers usually start everything for what we have on the data. Okay, the data is key A, key L, and key gas, and A of the pipe. Okay. Now let's go back to the slip and no slip. Okay. And one is if you want slip and no slip. So if we want to the average of properties of liquid properties or gas properties, for example viscosity of slip, okay, they call it S. So viscosity of gas multiplied by, because it is a slip, H1 minus HL plus viscosity of liquid multiplied by H liquid. So if it's no slip, so mu gas multiplied by 1 minus the L plus mu gas multiplied by lambda L. So the treatment is almost the same if you have water also. So you have this one, you have a density also, the same thing, the same treatment. You have the system no slip. So the same thing, if you have a liquid also, this is a water cup plus density of oil 1 minus water cup. Remember, or FO in the book. So this is treatment that's the same thing. So viscosity slip, density slip, density no slip, density liquid, also viscosity of liquid, the same thing. We use the same thing as this one. So this is the basic parameters that we will have in the two-phase flow. And I will show you again. We finish with the properties here. So remember that you have a slip, and you have HL. And one more thing is flow pattern. What is a flow pattern? It's the pattern of a flow in the tubing. So we'll talk about it when we go back to the book, okay? Back to laptop.